When you do these problems for 6.3, I really would just focus first on visualizing what's happening. For instance, this thing is a base of 3, and just visualize the fact that the graph goes through 0, 1 in its growth. And then understand that I'm going to move it -1, left 1, and up 2. So this is basically what's happening. You're taking this graph, you're going left 1 and up 2. And understanding that visualization, I think, will help you when you start getting in all these characteristics. So like, just try to visualize this problem. We go through this point with growth. This is a negative, so from the fall, that will reflect, and then I'm going to move it to the right 3. If I do it that way, 1, 2, 3 over here-ish, if I do it that way in my brain, then when I start doing all the nitty-gritty points and characteristics, it won't be so hard. So like if I look at number 4, I'll do all the little pieces of this one. What you're going to do is you're going to focus on the base. The base is a half, and then you're going to put numbers that we've talked about from the x-axis, -1, 0, and 1, and you're going to make your key points. -1 reciprocates the base to 2, 0, 1. Every problem has that y-intercept of 0, 1, and then 1 the base. And you're going to graph those points to start. So you come over here and you graph -1, 2, 0, 1, and 1 and 1.5. Then you're going to do what you did in the fall. If you have a negative a, right, so a is -1, you're going to multiply your outputs by -1, making this -2, -1, and -0.5. You don't change your inputs. That would be a b. And these don't have one because b is the base. So now what you do is you do that multiplication. This should be at -2. Remember, it's not stretching. It's being multiplied by -2 and regraphed at -2, -1, and -0.5, these values right here. And then once I do that, I look at my h value. My h value is -2, which is going to move to the left, and my k value is 0, which means it's not going to move up and down, which means the asymptote isn't going to move. Notice my asymptote is y = 0. So I'm now just going to move this to the left too, not the blue ones. Make sure you do it in order. I left off at these ones. So 2 to the left, 2 to the left, 2 to the left, there's my graph. And then from there, you can very easily do the characteristics. It doesn't have an x-intercept, does not exist. My y-intercept is weird, so let's find it. You plug 0 in, which gives you 1/2 to the second power, but it's negative, so -1/2 to the second power is -1/4. Asymptote's at 0. If you want to graph it a little bit closer to the asymptote, no problem. This is actually growth because of the reflection. The domain is -infinity to infinity. It is for every problem. The range, just be careful, right? Do the beeping. -infinity, beep, stop. -infinity to 0. The end behavior is to just write the domain vertically and match up the range with it. At -infinity, the graph is going to -infinity, part of the range. At infinity, the graph is going to 0. And that's pretty much how every problem works. If I come down here and look at this one, look, I start off with my key points of a half, right? So -1, 1/2 gets reciprocated to 2. 1/2 to the 0 is 1. 1/2 is the base, so I have that. Then I multiply everything by 3, so I have 6, 3, and 3/2. So if you want to, you can just start on the red ones. You can just graph -1, 6, 0, 3, and 1, 1/2. Or you could start with the blue ones and then stretch, however you want to do it. And then the h is 1. Again, in this problem, I have a k of 0. So I just move everything right 1, and I get my graph and my characteristics. Now your y-intercept, again, you're going to plug 0 in here. You have to do a little more work. You get 3, 1/2. If I put a 0 there, it's to the -1. -1 reciprocates, giving you 2. 3 times 2 is 6. So let's do one that, that has an e in it and has everything. So for an e, you would do -1, and you would focus on the base. So you'd have -1, 1 over e. E to the 0 is 1. E to the 1 is e. Then I'm going to multiply the outputs by negative. So I have -1 over e, -1, and -e. So I graphed the blue one so you can see it. 1 over e is a third. 0, 1, everything has that. And then 2.7. And then from there, what I did was I multiplied by negative. So I have -1/3, -1, and -e. You could just start with those red ones if you want, if you understand what's happening. And so then I looked at h. H is telling me to go back 2, and then k is telling me to go down 1. Always start with your asymptote. So the asymptote tells me to go to -1. You always draw that first because that'll help you know your pointer in the right spot. So I go to the red ones and I go left 2, down 1, left 2, down 1, left 2, down 1. And that gives me my graph and all of my characteristics. Now in this problem, I have a crazy y-intercept, right? It's -e squared minus 1. And, that's not a problem. And actually, in many ways, it's actually easier. Up here, I had to actually do math and figure out that it was 6. Over here, I just have to write that down, right? And to show you that that makes sense, let's go to Desmos. If I type in y equals -e, and by the way, when you do exponents, it's best to say x plus 2, and then highlight, and then raise to a power. And then -1, I can see my graph. I don't like that it's by 10s, so I can zoom in so it's by 5s like my graph. I can change it to be blue if I want, okay? And then, well, what's the intercept? The intercept's right here. It's some crazy number, -8.389. If I type that crazy e thing in, watch, -e to the 3rd power, and then -1 it's saying, look, hold on, e to the 2nd power. There we go. Typo. So -e squared minus 1 is -8.389, which is exactly what I get when I click right here and it tells me it. Keep in mind on a test, I want this crazy e answer. And you're not allowed to use Desmos on a test. Because, watch what it does in like this example. If I type this one in, 3 parentheses, a half, raised to, right? So raised to the, actually, I'm going to tell you again, it probably is a better idea to say x minus 1 and then raise it to the power. It just works better. You can just go right to the graph and see, oh, there's the intercept, 0.6. So you've got to be able to do it by hand and not use Desmos, but use Desmos to help you while you're doing your homework. On the back, you do it the exact same way, right? You're going to take your asymptote here and start with that. My asymptote is k is -2. In fact, you can just go ahead and put that in your answer blank right there. And then what you do is you say, well, did he move the intercept that's supposed to be at 0.1? First move it the same way you did k. I move it down 2, and I don't see it. So look for a crosshair. There it is. And that will give you h. h is 1. So if you put it all together, you would have f of x is equal to 3 to the x opposite h minus 1 minus 2. And you can check that on Desmos to make sure as well. You go on to Desmos, you type in the answer you think it is, 3, don't forget, x minus 1, then hit the exponent, and then minus 2. Let's see, I have an intercept right here at some weird number that one does. Same thing there. It looks like the exact same graph. We did a great job. So even when you have a problem that has e's on it and such, it's the same process. You go to k. K in this case is -3. You start with your intercept. You move it down the same amount of k, and you try to see if I moved it over, which I did in that problem. Look at this one. This one, I start with k is 2, and I realized, oh, he reflected it. So this is important to understand that the intercept with reflection is actually at -1. So that if you say k is +2 and you move it up 2, it actually didn't move. And that one is actually fairly tricky for students because they're like, hey, Mr. King didn't move it. Yeah, but I reflected it. So it is, in fact, just k and a negative reflection. Down here, we have an SOL question where you need to set this equal to 0 and solve. You're going to add 243 on both sides and log base 9. On Desmos, you can actually log base 9. The way you do that is you would find it under functions and then miscellaneous functions, log base. So you could put whatever it's going to be in there. And then this one right here, the last one, is very easy to do if you think about transformations. Because if you look at this problem and you think about transformations, this graph is a not reflected. There's no reflection. So that negative can be canceled out, and that negative can be canceled out because there's no reflections, and then you just figure out, well, from there, which one is it. I hope this helps. Please ask additional questions in class.